Okay, when we're solving trig equations, we want to get x by itself, so we do all of our basic simple math, of course, first. So we would want to divide both sides by 2 in order to get the 2 away from the cosine. So you want to get the trig thing by itself. So we're left with cosine on this side and negative root 3 over 2 on that side. So now we can answer this question. Some teachers like you to take the inverse of both sides to get x completely by itself. So we could do this, because that's how you get rid of a trig value, is by inversing it. So x is the inverse cosine of negative root 3 over 2, which says this. This is what it means. At what angle, potentially on the unit circle, is the cosine value negative root 3 over 2? That is what this question is asking you to find. So hopefully you know your unit circle really well, or all of the values. If not, maybe your... So those are the two places where the cosine value is negative root 3 over 2. So that was, once again, 5 pi over 6 and 7 pi over 6, both places on the unit circle where the cosine is negative root 3 over 2. Gave you some. Okay, so let's do another one. Here we have 2 sine of x minus 1 equals 0. So the easy math says minus 1 first. So 2 sine of x equals negative 1. And then we divide both sides by 2. So we're looking at all the places on the unit circle where the sine of x is negative 1/2. Okay, so if we go back to our super, would be the 2 spots at 7 pi over 6 and at 11 pi over 6. Are the 2 places on your unit circle between 0 and 2 pi, mind you, where the cos or the sine of the x or the x value is 1/2. So here's another one. Notice we have to first divide both sides by 2 to get rid of the 2, and then I have sine squared equals 1/2. Okay, so we solve trig squareds just like we solve x squareds. So we will square root both sides. Okay, and that gets rid of the square, so I still have sine. And over here, when I take the square root, you need to remember we have positives and negatives. When we square root things in higher math classes, we get positives and we get negatives. Okay, so looking at our unit circle, we probably will notice that there's no place where the sine value is the square root of 1/2. So we have to manipulate this a little bit by using some laws of radicals. So I can take the square root of the numerator and denominator separately. Okay, and the square root of 1 in the numerator is just 1, and then root 2 has to stay on the bottom, which probably is not on your unit circle either. But if we multiply by the denominator, okay, if we rationalize this, that's what it's called when you do it, we get root 2 over 2, positives and negatives. Positive and negative root 2 over 2. So now we have to go to your unit circle and decide where on the unit circle is the sign positive and negative root 2 over 2. So hopefully you know that that's at pi over 4. At 3 pi over 4 is where they're both positive, and it's negative at 5 pi over 4 and at 7 pi over 4. So these are the 2 places where it's positive root 2 over 2. These are the 2 places where it's negative root 2 over 2. So you have to remember when you are taking a square root that you get positives and negatives. Okay, here pretty basic. We're going to add 3 to both sides. to get the tangent thing by itself again. And then square rooting gives the tangent value a positive and negative root 3. So once again, if you look on your trig chart, we're looking for when is the y value root 3 over 2, and when is the tangent value 1 over 2. Okay, positives and negatives. And this happens at pi over 3 is where it's a positive 1. Okay, 2 pi over 3, it's negative, so we'll include that one. And then at 4 pi over 3, it's positive again, and at 5 pi over 3, it's negative. So at all four of those angles, the tangent is either positive root 3 or negative root 3. Okay, now this fancy trig equation is a quadratic trig equation. And we're going to solve this quadratic trig equation just like we solve regular quadratics by factoring. So we can write down, this is very similar to 2x squared plus 3x plus 1 equals 0. Okay, that would be the quadratic equivalent of this trig equation. So this one would factor to 2x plus 1 and x plus 1. Okay, in the quadratic one from here, that would be the factors. So our trig equation is going to factor to something very similar, to 2 sine plus 1 and sine plus 1. Okay, this is the trig factorization of this quadratic trig equation. So everywhere we have an x, you just put a sine instead. So trig equations behave very much like regular algebraic equations. And as such, we need to figure out if this thing is going to be 0 or if this factor will be 0. Okay, so we factor them so we can set each of these factors equal to 0. And I'm just going to solve this right away. So sine is negative 1/2. We subtract the 1 and then divide by 2. Or the sine is negative 1. And if you know your unit circle, the sine is negative 1/2 at 7 pi over 6 and at 11 pi over 6. And the sine is 1 at pi over, oh, this is negative 1, huh? 3 pi over 2 is where the sine is negative 1. So those are your three answers for this quadratic trig equation. An amazing trig superchart. So we want to figure out cosine. So here is the cosine row, and we want to figure out when is it negative root 3 over 2. So there's a negative root 3 over 2, and here is a negative root 3 over 2. So the answers are 5 pi over 6 and 7 pi over 6. Here, and we get rid of these other things. We're looking for where sine is negative 1/2. And it looks like that happens, go away, here at 7 pi over 6, and here at what looks like 11 pi over 6. So the two answers to this trig equation